Solving trigonometric equations part 3. The prerequisites for understanding this video are your expertise with unit circle, or if you don't remember it very well, have it as a reference. And then periods of sine, cosine and tan functions. Periods of sine and cosine are each 2 pi, and that of tan is just pi. And then, depending on the problem, you may be asked to recall one or more trig identities. Now, the most commonly used trig identity is cosine square plus sine square equals 1. So that one I hope you remember. And the more identities you remember, the more problems you will be able to solve. So let's start with some examples. First example I want to consider is this. Solve 1 plus sine theta equals 2 cos square theta. Now notice I have sine and cosine, but cosine square I can write as 1 minus sine square. So that's what I meant, that you will be called upon to use a trig identity. Cos square plus sine square equals 1. So cos square is 1 minus sine square. So now we have changed everything to sines. So let's go ahead and simplify on the right side and distribute the 2. You get 2 minus 2 sine square theta. Now move everything to the left. So add 2 sine square theta on both sides. You get 2 sine square theta, and just plus sine theta, that's already on the left side. Now I have a plus 1, and if I subtract 2, I get minus 1 equal to 0. So now we can solve. We can let x be equal to sine theta. Then we get 2x square plus x minus 1 equal to 0. And we can factor this. The factors are going to be 2x and x to begin with. And then I need a minus 1. So one of this is minus, the other is plus. I know that I need a plus 1x. So I better have 2 times plus, that is 2, minus 1 here. So I get 2x minus 1 equal to 0, or x plus 1 equal to 0. And when I add 1 on both sides, I get 2x equals 1, or x equals half. And from here, I get x equals negative 1. Now, x was sine theta, so I'm going to write sine theta equals half. And from here, I get sine theta equals negative 1. Now, since the period of sine is 2 pi, I'm going to find all those values of theta in the interval 0 to pi. So in the interval 0 to 2 pi. So where is sine theta equal to half? Now, if you remember your unit circle, you would say theta equals either pi over 6 or 5 pi over 6. Now for this, you would say theta equals pi. So let's continue this. Theta equals pi over 6, 5 pi over 6, or theta equals pi. And since the period of sine is 2 pi, we can add multiples of 2 pi to each of these. So our general solution will look like this. Theta equals pi over 6 plus 2n pi, or 5 pi over 6 plus 2n pi, or pi plus 2n pi. So that's our solution. Now let's look at another example. So this time I have sine 2 theta minus cos theta equal to 0. Now to solve this example, I realize sine 2 theta is 2 sine theta cos theta. So that's the double angle identity minus cos theta equal to 0. So now if I factor cos theta, then I get 2 sine theta minus 1 equal to 0, which means I can set each factor to 0. Cos theta equals 0 or 2 sine theta minus 1 equal to 0. Now again, in the interval 0 to 2 pi, what are the values? Where is cos theta equal to 0? So in this interval, in one revolution, I know cos theta is 0 when theta is pi over 2. This is from the unit circle. And also at 3 pi over 2. Alright, here we have to do some work. We first add 1 on both sides and then divide by 2. And I get sine theta equals half. So sine theta equals half. Again, in this interval, where is it half? It's at pi over 6 and 5 pi over 6. So what is the general solution going to be? So general solution, you keep on adding multiples of 2 pi because each of these, cosine and sine, has period of 2 pi. So you would write pi over 2 plus 2n pi. So this is saying add multiple of 2 pi. Or 3 pi over 2 plus 2n pi. Or pi over 6 plus 2n pi. Or 5 pi over 6 plus 2n pi.